Okay, so we are continuing. We had some intervals of increase graphed, and we were just about to get our intervals of decrease to go along with them. So we'll graph again just the original f of x function with those squiggly brackets for our intervals. Now we're going to have x values that are between, so we're going to go from negative square root of 3 less than x less than negative 1, comma. We want negative 1 less than x less than 1, comma. And we want hold on, I have something incorrect up here, so I'm going to have to fix that. We went to infinity, that's not going to be true. Let me go back and look at my original page so I can fix that. Increase, decrease was right here. Oh, that last one was supposed to be 1 to square root of 3. I must have just been looking somewhere else, so I have that last one incorrect. It needs to go 1 to square root of 3. So this one should have been, always good to check. So 1 to square root of 3 right there. All right, so now we can do on the end here, comma 1 less than x less than square root of 3. Close curly brace. Okay. 2 close curly braces, just want 1. Okay. And that was supposed to be red, I believe, and dashed. Okay, so I look back at my project. Yep, dashed and red. Okay, so we can see if we collapse this, we've got our intervals of increase and intervals of decrease highlighted out there by those colors. Okay, all right. The next thing that we want, that finishes part F, is to regraph those critical points with their new labels. Okay, so I already had them up here, so I can copy them real quick. And that one's probably the easiest one to type, but it's okay. If I copy at least just one of these, I can get the other one. And I'm regraphing them. I want these in this folder, so hold on. I forgot, somehow when I switched to the new video, I must have stepped out of the folder. I'm just dragging these over and up into that folder so that I can have all that in the folder where it was supposed to be. Okay, so those are all the points in their folder now. They're all supposed to be black, and they need to have labels that say maximum, minimum, or neither. Okay, so let's just color them real quickly. They're still black, so all my points are going to be black here. And they need to have their labels. So 0, 0, this one was neither. I graphed that point again because now it's showing up with the 0, 0 ordered pair label from the first time I graphed it, and the neither label from the second time I graphed it. And the next one is supposed to be the maximum. And then the last one is supposed to be our minimum. Okay. Oh, I have to take off the negatives, of course. There we go. Now it's going to look better. There we go. Now, if the positioning of the labels is not good and you would like to change it, you can do so. If you click on the wrench on any of these, you can change the positioning of the label and the size of the label, even if necessary, the orientation of the label, if you have too many things combined. So I'm going to leave them alone for right now. But if there is too much too close together, you can always change those things. Okay. Now it asks me, now that I've done those, to collapse the folder. So when I go back up to this folder, everything, oops, arrow, everything should collapse. But I don't have all that in addition to all this back up here. I may go up and put a new folder in there just to add a general folder, but hopefully our list won't be getting super long there. If something isn't in your folder, again, you can just drag it and put it in the appropriate folder. Okay, so then the next part is all that stuff with concave up, concave down. So we're going to make a new folder for concavity. And in that folder, we need a few notes to start. So we need the test intervals, intervals of concave up, intervals of concave down. So first, our test intervals. Okay, so our test intervals for concavity were, I'm flipping back to my page just to remember, here's our test for concavity. We already did it by hand. So if you haven't done it by hand, you would do that first. Our test intervals concavity are negative infinity to -1, union -1 to 0, union 0 to 1, union 1 to infinity. Okay, and then our concave, I believe I said to do up first. Let's double check. Yep, up first. So concave up will be on the interval. We have -1 to 0, union 1 to infinity, and then I forgot the note, so put that in there, note concave down will be on the interval -infinity to -1, union with 0 to 1. If it's not clear, I'm just hitting a capital U for the union symbol. It looks close enough. Okay. Okay, so I've got those notes. Now I need a note to classify. And so the second order critical value was x equals 0, so we do have an inflection point. So we're going to say inflection point at x equals 0. That is an inflection point, because the concavity changed. I got that note for part D. It doesn't hurt for you to label these as well. So like A, if you are doing your actual project, putting in some labels in the notes may be helpful for you, just to make sure you haven't missed one. Okay, so I got all those. So I've done D. Now for E, we're going to use some inequalities to shade them. So I can't label the actual action lines, just the notes, but that's all right. So now I'm going to shade. Okay, so I'm going to shade my intervals of concave up. So I need to shade those two intervals. All right. Okay. Now I have to use inequalities, and I'm going to shade inside of the graph. So where the graph is concave up, that's going to be in these two regions. I'm going to shade inside the graph, inside the cup part of the graph. So we're going to graph above the function. So I want y to be greater than or equal to the function on those two intervals. So not on the whole function, as it's happened right now. So now I've got to put in the x values. So I want it to be concave up between -1 is less than or equal to x is less than or equal to concave up 0, comma, we're also going to do x is greater or equal to 1. That gets those two intervals. So I've got some concave up stuff shaded now. And I wanted to shade concave up in green and then the other one in orange. So we're going to shade this in green. By the way, the equal bar, if I don't put the equal bar in there, it's just going to have some more dashing going on, and it kind of hides my other dashing. That's the only reason I put the equal bar in. Technically, it doesn't really matter. It just helps make other stuff show up better when I look at all of it at the same time. If I turn that off, I can see the intervals of increase, decrease, and the concavity. So, all right. So that is kind of taking over right now, but let's keep looking at the next part. Now when I do the concave down, to be in that portion, I want it to be y less than or equal to the function. And the concave down stuff is on, I need to be x less than or equal to -1 and between 0 and 1. Okay, and I think that was supposed to be orange. Okay, so we've got our concave down portions and our concave up portions. So I wanted to shade inside the curve for those two portions. Looking good. Okay, so the next part, regraphing the critical values and giving them a label. Okay, oops, this one's not in the folder, so it's going to drag it up until it gets that line for the folder. And if I go to the undo, luckily undo works. And if I go to the end and hit enter, 0, 0, or 0, comma f of 0, it's 0, 0, comma f of 0. It's already been graphed several times, but now we're going to give it another label, and we're going to call it an inflection point, because it is. And all the points are going to be black, just to keep them consistent. So that point has 3 labels on it now. It's coordinates, it's neither for extrema, and it is an inflection point. Okay. And again, the choices were inflection point or not an inflection point. I didn't want to use neither because I already used the word neither before, and you don't want lots of points saying neither when you can't tell what that means. Okay, so collapse that folder. Okay, got all that good stuff. Then we are going to do, we are rational, so we're going to do asymptotes. We're going to do another folder just for organization, getting the hang of those folders. So asymptotes. And we had a couple. So do I need any notes? Nope, just gotta graph them. And they're all gonna be purple. So we start with our vertical, and we had 2 vertical, x equals 1 and x equals -1, and we had 1 oblique, and that was y equals 10x. Okay, we want them all purple and dotted. Dotted and purple. Dotted and purple, and so on. Okay, looking good. We got a bunch of asymptotes there in that graph now. Okay. I think that's all I need in the asymptote folder. Yep, so I'll collapse the folder, just a little organization there. Okay, and the intercepts. So just want to get some ordered pairs and find them exactly. So the ordered pairs we had were 0, 0. So one more. So we're going to graph 0, 0. And I think we're going to label it as an x-intercept. And a y-intercept. 0, 0 is a really popular point here. So it's also an x-intercept and a y-intercept. Okay, and I think I still want those to be black. Yep, just to keep all the points the same color. Trying not to have too many colors for different categories of things in our graph here. Got lots of plenty of colors going down. Okay. Okay, so this is where at 0, 0, look at all those labels. We might need to define where some of them go or how big they are, but it's okay. Got lots of cluster of labels there. And that's it. I've got all the things that this graph